The air on Vella La Vella, September 1943, is not air. It is a wet, hot blanket smelling of diesel, salt and rot. It hangs over the island, thick and vibrating with the sound of insects and idling D8 caterpillar engines. The battle for the island is technically over. The Japanese 13th Infantry is broken, its remnants fled into the unforgiving jungle. But for the men of the 58th Naval Construction Battalion, the Seabees, the real war has just begun. Their enemy is not a soldier, it is the ground itself. It is a solid mass of uplifted coral, sharp as shattered glass, dense as granite, and absolutely hostile to the machines of men. This is the new normal in the Central Pacific, a world of unbearable humidity, logistical nightmares, and the tyranny of the clock. Lieutenant Commander Paul Brick Larson, USNR, stands on a slight rise overlooking the planned site for the Barracoma airfield. He is not a career officer. He is a 42-year-old civil engineer from Montana, a man who understands mountains and granite, not this white skeletal landscape. His khakis are black with sweat. He kicks at a chunk of coral. It doesn't budge. It feels cemented to the earth. Around him the Seabees, battle-hardened and exhausted, are doing their best. Their heavy bulldozers grind and shudder, their massive steel blades screaming as they skip and shatter against the subsurface. It sounds like dentistry on a giant. Every man here knows the equation. No airfield means no fighter cover. No fighter cover means the Japanese Tokyo Express will continue to pound them from the air, unopposed. The atmosphere is one of weary, frustrated determination. A generator coughs to life, adding its diesel drone to the grinding metal. Larson watches a D8 operator, a kid from Ohio, reverse his machine. The bulldozer's blade is chipped, a massive shard of steel missing from its cutting edge, broken clean off by the rock. The operator shouts something to his chief, but the words are lost in the din. Larson doesn't need to hear them. He knows what they are. It can't be done. Not like this. He looks at his survey map, a perfect, neat grid drawn by an architect in Pearl Harbor who had clearly never set foot on a coral atoll. The map shows a 400-foot runway. Larson looks at the ground. The ground just stares back, white and defiant. A slight tremor in the air, a distant crump, reminds him the war is still close. He tastes salt and dust. The calm is heavy, pregnant with the impossible task ahead. Larson retreats to the command tent, a canvas oven that offers no relief from the heat. He wipes a film of salty grit from his face and unrolls the blueprints again. The directive from the Bureau of Yards and Docks is explicit. Standard excavation, grading, and application of Marston matting. Marston mat, the perforated steel planking, is the miracle material that allows them to build runways fast, but it requires a stable, level, graded subbase, the very thing this island refuses to provide. His operations chief, a weary chief petty officer named Stiles, enters the tent holding a broken auger bit. "It's no good, Lieutenant. We tried to drill for core samples. Went through 3 bits in an hour. This stuff isn't rock, it's not soil, it's something else. It shatters the drills, and the dozers are overheating. We're breaking blades faster than we can weld them." Larson nods, his mind far away. He's thinking about the timetable. Admiral Halsey's entire offensive in the Solomon Islands hinges on this airfield. They need it operational in 2 weeks. At this rate, it will take 6 months. Just then, the rhythmic drone of the camp is torn apart by a different sound, a high-pitched whine, followed by the unmistakable gut-wrenching crump, crump, crump of Japanese mortars. A washing machine Charlie is flying overhead, unseen, correcting the fire. Men shout. Larson and Stiles drop to the dirt floor of the tent. The mystery is gone. It is replaced by a brutal, simple equation. The Japanese know exactly where they are and exactly what they are building. They are in a race. The ground shakes again. "They're ranging us, sir," Stiles says, his voice muffled. "They know this is the only flattish piece of ground on this godforsaken island." Larson feels the cold dread of incompetence. Not his own, but the incompetence of the doctrine. The manuals he was given are useless. The tools he has are breaking. He looks at the blueprint, now covered in a fine layer of dust from the mortar blast. Standard excavation. It's a death sentence. He looks at the broken drill bit in Stiles' hand. The coral doesn't just resist, it fights back. What he didn't know was that this moment of profound failure was the catalyst. To win this race, he would have to throw the book away and write a new one, not with ink, but with high explosives. The problem, as articulated in urgent dispatches from Sintipak, Commander-in-Chief Pacific Fleet, to the War Department, is one of strategic velocity. The entire island-hopping campaign, championed by Admiral Nimitz, is not about capturing territory. It is about capturing runways. Each island is an unsinkable aircraft carrier, a stepping stone for the B-25 Mitchell bombers, and eventually the new long-range B-29s. But these carriers must be built. A field report from the earlier landings at Guadalcanal, Henderson Field, illustrates the nightmare. Heavy equipment, vital for grading, is rendered 40% non-operational within 72 hours due to subsurface coral formations. Standard excavation methods are proving catastrophically slow. The importation of suitable aggregate from offshore quarries is time prohibitive and exposes vital transport shipping to enemy submarine action. This is the cold, technical reality. A 500-foot runway capable of handling a heavy bomber requires a sub-base of crushed, compacted aggregate. In the United States, this aggregate is quarried, crushed at a plant, and trucked to the site. In the Pacific, there is no quarry. There is no truck fleet. There is only the island itself. The standard procedure is to laboriously excavate the faulty coral rock, haul it away, and replace it with better fill, either dredged from the lagoon or impossibly shipped 500 miles from Pearl Harbor. The construction battalions are caught in a logistical trap. They are given timelines of 14 to 21 days to build bases that, using 1943 technology and doctrine, require 60 to 90 days. Every day of delay is another day that the U.S. Navy's carrier fleet must remain in hot waters, exposed to Japanese air and submarine attacks, just to provide fighter cover for the men on the beach. An after-action report from the Tarawa campaign is even more blunt. The 2nd Marine Division secured Betio in 76 hours. The 5th CB Detachment, landing under heavy fire, estimates 45 days for runway rehabilitation. The primary obstacle is not the enemy, but the geology. The coral atolls are not sand. They are the skeletons of millennia of marine life, fused and compacted by time into a substance that is neither rock nor soil. It defies excavation. It resists drilling. It shatters steel. The CBs, the most capable body of military engineers in the world, are being defeated by geology. They are using 10-ton bulldozers as pickaxes, and they are losing. The war in the Pacific is not just a war of men. It is a war against time, logistics, and the earth itself. The human cost of this technical failure is measured in the field hospital tent, 200 yards from Larsen's command post. The air inside is suffocating, a miasma of sweat, blood, and gangrene. The washing machine Charlie mortar attack has added 12 new patients. A Navy surgeon, his arms bloody to the elbows, looks up as Larsen enters. "Don't just stand there, Lieutenant. I need these men out. They need plasma. They need real surgery. They need Pearl." He gestures to a young Marine, his leg wrapped in a sodden, dark bandage. He'll lose that leg if he's still here in 48 hours. The C-47s can't land. You know that, right? Your strip is just 1,000 feet of ruts and coral heads. It's shearing the landing gear off the transports. The surgeon's words are a heavier blow than any mortar. The statistics from the sink pack reports become faces. They become the shallow breathing of the Marine on the cot. This is the consequence. An unbuilt runway is not a logistical delay. It is a death sentence. It means the wounded cannot be evacuated. It means the vital F-4U Corsairs and P-38 Lightnings cannot land to refuel and rearm. It means the men who just fought and bled to take this island are left exposed, withering on the vine, while the Japanese consolidate on the next island. The morale of the Seabees is cracking. They work 18-hour shifts under a blistering sun, drinking flat metallic water, only to watch their multi-ton machines break against an immovable object. They are builders, and they are being told to build a highway out of diamonds with wooden spoons. Experts at the Bureau of Yards and Docks agreed. It couldn't be done. If this battle against the elements fascinates you, stay with us. The solution came not from a manual, but from an act of pure desperation. Paul Brick Larsen was not born for the sea. He was born in 1901 in Butte, Montana, a world of granite, copper, and cold mountain air. He is a man of the high, dry plains, shaped by the American West. At 42, he is older than most of the officers, a citizen sailor recruited directly into the Naval Reserve for a single specific skill. He knows how to break rock. He spent 2 decades as a civil engineer for Anaconda copper mining. His specialty was not building, it was demolition. He built roads by blasting through mountainsides. He sank mine shafts by understanding the precise application of dynamite, how to make thousands of tons of rock do exactly what he wanted. He understands fracture mechanics, stress lines, and the subtle, violent poetry of a shaped charge. He joined the Seabees in 1942 out of a quiet, pragmatic patriotism. The Navy didn't know what to do with a 41-year-old mining engineer from Montana. They gave him a commission and sent him to the Bureau of Yards and Docks, where he chafed under the rigid bureaucracy. He hated the standard issue thinking, the assumption that a procedure that worked in Virginia would work on a Pacific atoll. He saw the world not as a set of rules, but as a set of physics problems. His mind was a calculator of angles, pressures, and load-bearing capacities. His nickname, Brick, is a misnomer. He is not blunt, he is dense, solid, and utterly reliable. He carries a dog-eared notebook everywhere, filled not with orders, but with equations and crude cross-sectional drawings. This background makes him uniquely unsuited for the naval hierarchy, but perfectly suited for the problem at Vella La Vella. He is not a military strategist. He is a demolitionist. While other officers see a surface to be graded, Larsen sees a rock face to be quarried. He is not intimidated by the coral's hardness. He is intrigued by its structure. He knows from his mining days that the hardest rock is often the most brittle. He understands that trying to scrape it is futile. You cannot scrape a mountain. You must break it. This thinking, born in the cold, hard geology of Montana, is the key that will unlock the Pacific. He is the right man, with the right unconventional experience, standing in exactly the right place at the moment of greatest desperation. The idea arrives not as a flash of genius, but as a whisper of memory. Larson is standing by the broken D8 bulldozer, watching the exhausted mechanics try to weld the fractured blade. The tropical sun is a hammer. He closes his eyes, and for a second he is not on Vella La Vella. He is back in Montana, 1934, on a road-building project in the Rockies. They had hit a shelf of granite that stopped them cold. They couldn't truck in aggregate. The contractor was panicking. What did he do? He didn't dig the granite out. He drilled into it. He shot it. He planted charges not to obliterate it, but to fracture it, to pulverize it in place, turning the obstacle itself into the solution. He used the blast to create his own aggregate. He opens his eyes. He looks at the white, defiant coral. "Stiles," he says, his voice quiet. "Get me the demo team. And the drill augers. All of them." Stiles is confused. "Sir, we need those for the command post bunkers." "No," Larson says, a new cold energy in his voice. "We're going to drill the runway." The idea is absurd. It is profoundly dangerous. They are on a narrow strip of land surrounded by fuel dumps, ammunition caches, and the field hospital. He proposes to detonate tens of thousands of pounds of dynamite. He goes to the battalion's commanding officer, a traditionalist Navy captain. He explains his plan: drill a grid of holes 10 feet deep across the entire 400-foot length plant charges and detonate it all. Pulverize the coral subsurface, then use the bulldozers to grade the resulting gravel. The captain is horrified. "Lieutenant, you want to set off the single largest non-nuclear explosion in naval history, 300 yards from my command post. On an island we haven't even finished clearing of snipers. That's the stupidest thing I've ever heard." "Sir," Larson replies, his Montana drawl suddenly pronounced, "your way. We'll be here until Christmas, and we'll be burying half the men in that hospital tent. My way. I can give you a runway in 3 days." The captain glares at him. "You will do no such thing. Your orders are to follow the Budoc's procedure. That is final." Larson looks at the captain, then at the broken bulldozer blade. He nods. "Yes, sir." He walks out of the tent, knowing he has to do it anyway. He will conduct a test tonight, far from the command post, whether the captain approves or not. The test site is a 100 by 100-foot square on the far western edge of the proposed strip, shielded from the main camp by a small rise and a stand of blasted coconut palms. The time is 200. The only light is a sliver of moon and the blue-filtered beam of a single jeep's headlamp. The air is still, the jungle sounds amplifying the clink of metal on rock. Larson and his accomplice, Chief Stiles, have brought a small pioneer team, 10 men they trust, men who are desperate enough to try anything. They have reallocated 2 crates of 60-pound satchel charges and a dozen hand augers. The work is brutal. The coral fights them every inch. They aren't drilling. They are chiseling, pounding, and sweating, driving the augers into the rock with sledgehammers. They manage to sink 15 holes, each 6 to 8 feet deep, in a precise grid pattern. The humidity is so high that their hands slip on the tools. "This is insane, Brick," Stiles whispers, wiping sweat from his eyes. "If the captain catches us, we're headed for the brig." If we don't do this, we're headed for a coffin, Larsen mutters. Keep drilling. He moves from hole to hole, carefully lowering the charges. He is not a soldier, he is an artist. He is calculating the blast wave, the heave versus the shatter. He doesn't want to create a crater. He wants to pop the subsurface, to use the rock's own resistance to crush itself. He wires the charges together with primer cord, his hands steady, the engineer in him completely focused. By 0400, they are done. The 10 men take cover behind a wrecked Japanese Type 95 tank 200 yards away. The silence is absolute, broken only by the chirping of insects and the distant surf. "Fire in the hole!" Larsen shouts, his voice sounding small in the vast, dark expanse. He pushes the plunger on the detonation box. For a terrifying second, nothing happens. Then the ground jumps. It is not the sharp crack of a high-explosive shell. It is a deep, muffled whump, a colossal underground punch. The earth visibly swells, a bubble of white dust and pebbles rising 50 feet into the air, and then settles. A rain of small, light coral fragments patters against their helmets. The silence that follows is deafening. They wait a full minute before moving, the air thick with pulverized coral dust that smells like a dentist's office. Larsen and Stiles walk out onto the test pad, their flashlights cutting through the haze. Stiles stops dead. He reaches down and scoops up a handful of the ground. Where there had been an unbreakable sheet of rock, there is now a foot-deep bed of perfectly graded, gravel-like aggregate. It's warm to the touch. "My God, Brick!" Stiles whispers, letting the white gravel run through his fingers. It's perfect. We made aggregate." Larsen just nods, his mind already scaling the calculation. He's figured it out. He now knows the exact depth, the exact charge, the exact pattern. He knows how to build his runway. If stories like this fascinate you, stay with us. The next chapter of wartime innovation might surprise you. The unauthorized detonation at 0400 sends a shockwave, both physical and political, across the encampment. The captain is in Larsen's tent before sunrise, his face a mask of cold fury. "Lieutenant Commander, you are in violation of a direct order. I heard an explosion. Report." He is flanked by 2 Marine guards. The confrontation is not a shout. It is a cold, quiet tribunal held in the suffocating heat. Larsen, covered in white coral dust and grime, does not salute. He is too tired and too certain. He gestures to a large canvas sack on his cot. "That's my report, sir." Stiles empties the sack onto the captain's field map. A pile of white, gravel-sized coral chunks spills across the neatly drawn lines of Vela la Vela. That, sir, is load-bearing aggregate. Per the Budoc's manual, that is what we are required to place before we lay the Marston mat. We can't dig it, we can't ship it, but as of 0400 we can make it. The captain stares at the gravel, his anger momentarily eclipsed by curiosity. He picks up a piece. "You did this with the explosion?" "Yes, sir," Larsen says. "It's a mining technique, subsurface pulverization. The coral is hard, but it's brittle. A low-velocity confined blast doesn't crater. It fractures. It shatters the subsurface in place. It does in 1 second what those bulldozers can't do in a month." "You risked this entire position," the captain counters, his voice rising. "Our primary fuel dump is 500 yards from your proposed quarry." "The 58th CBs have lost 30% of their heavy equipment in 48 hours, sir," Larsen says, his voice flat, presenting his defense. At this rate of attrition, we will be non-operational by Friday. The Japanese will bomb us back to the Stone Age before we can even grade 100 feet. The standard procedure is a failure. It's getting men killed. He points to the hospital tent. The surgeon has 12 men who will die if they aren't evacuated in 48 hours. I'm offering you a 40-foot runway. In 48 hours, give me the 58th and all the dynamite we have. I will give you your airfield. A long, tense silence fills the tent. The captain looks at the gravel. He looks at the casualty reports on his desk. He looks at the unyielding engineer standing before him. You blow up my fuel dump, Larson, and I'll have you shot myself. Proceed. The scene explodes from the quiet tension of the tent into a symphony of controlled chaos. This is the real test. Larson is not just building a runway, he is conducting an orchestra. The entire 58th CB Battalion, nearly 100 men, descends on the 40-foot strip of coral. The operation is a breathtaking display of engineering and brute force, executed with battlefield speed. The percussion begins first. Teams of CBs, working in shifts, man the portable augers. They drill hundreds of holes in Larson's precise grid, a task that takes 24 solid hours of back-breaking labor. They are followed by the demo teams, feeding the gopher holes, carefully lowering charges of TNT and primer cord. Larson himself walks the entire line, checking the wiring, ensuring every connection is perfect. This is not demolition, it is industrial-scale sculpture. At 600 on the second day, the island is evacuated to its perimeter. Fire in the hole. The detonation is not a single blast. It is a rolling, rhythmic whump, whump, whump that travels the length of the runway. The ground heaves in a massive 4,000-foot-long wave, a white cloud of pulverized coral dust blotting out the sun. The sound is felt more than heard, a solid punch to the chest. Then the brass section begins. Before the dust even begins to settle, the roar of 100 diesel engines cuts the air. The fleet of D8s, graders and rollers, which had been useless against the solid rock, now charge. They are not digging, they are pushing. They level the pulverized, blast-loosened aggregate, spreading it like soil. The magic, Larson's final insight, happens next. The Seabees bring in water trucks filled with salt water from the lagoon. They douse the freshly graded coral gravel. A chemical reaction, instantaneous and profound, occurs. The lime in the pulverized coral, activated by the heat of the blast and mixed with the salt water, begins to set. It is coralcrete. It is a natural cement, hardening almost as fast as they can roll it. Within hours, the surface is not just stable, it is harder than any asphalt. An official field report, filed 46 hours after the operation began, states simply, Barracoma Airfield is operational. Runway 14, 100 feet. Surface hardness exceeds specifications. The recognition comes 3 hours later. A C-47 transport, heavy with wounded men, makes a perfect landing. As it taxis past the command tent, the pilot spots a dust-covered Larson and gives a sharp salute. The war in the Solomons has just been changed. The stupid idea becomes official doctrine with astonishing speed. It is given a dry, technical name, the Hansen Method, named for Commodore C.H. Hansen, the head of the Seabees, though it was men like Larson on the ground who perfected it. The method is refined and repeated across the Pacific. What took 46 hours at Vela La Vela is soon streamlined. At Kwajalein Atoll, The 109th CBs build a 5,000-foot runway in 72 hours. On Eniwetok, it's done in 60. The island-hopping campaign, once throttled by the impossible logistics of airfield construction, accelerates into high gear. The unsinkable aircraft carriers are now being built at a speed the Japanese High Command cannot comprehend. Their strategic calculations, based on months of delay, are rendered obsolete in a matter of days. The long-term consequences are staggering. The entire B-29 Superfortress campaign, the one that will ultimately bring the war to an end, is made possible by this technique. The massive air bases on Tinian and Saipan, from which the Enola Gay will later take off, are built using Larsen's coral blasting method. These are not just dirt strips. They are some of the largest, busiest airports in the world, built in weeks from the very islands they rest on. The concept of in situ resource utilization, using the materials you find on site, becomes a cornerstone of modern military and civil engineering. The speed of the American victory in the Pacific is inextricably linked to this one engineer's refusal to accept the impossible. Paul Brick Larsen himself is awarded the Legion of Merit for his unorthodox and highly effective methods. But his name is quickly buried in the archives of the Bureau of Yards and Docks. He is a humble man, an engineer, not a warrior. After the war, he is discharged from the Navy. He returns to Montana, to the cold, solid mountains he understands. He goes back to building dams and mining roads, his revolutionary contribution to the war effort a footnote in a technical manual titled Advanced Airfield Construction in Coral Atolls. He rarely speaks of the war, content to solve the problems of rock and gravity. A quiet man whose stupid idea helped shrink an ocean and win a war. The problem faced by Paul Larsen on Vella La Vella is, in its essence, a universal one. It is the same problem faced by engineers planning a response to a hurricane-devastated coastline, where all infrastructure is gone. It is the same problem faced by NASA scientists planning a base on the Moon or Mars. You cannot ship a runway. You cannot pack a highway. You must inevitably build from what is there. The Hansen method is the direct ancestor of every modern plan for lunar regolith concrete, for 3D printing habitats from Martian soil. It is the philosophy of turning the obstacle itself into the tool. It proves that the most profound innovations are not born from consensus or committees. They are born from necessity, ignited by a single stubborn mind, defying the tyranny of standard procedure. The greatest leaps forward often look like acts of madness to those who are bound by the past. Larsen's idea was called stupid because it was dangerous, unproven, and terrifying. But it was also brilliant. It recognized that the enemy, the unbreakable coral, held the key to its own defeat. The runways of Tinian, built from the island's own shattered bones, are silent now, slowly being reclaimed by the jungle. But the concrete, forged in 48 hours of desperate genius, remains. It is a hard, white scar on the earth, a testament to the war against the clock, and a silent witness to the power of one idea to change the world. Every great idea begins as an act of defiance against impossibility. What impossible ideas do you think could change the world?